Now let's solve some problems from the book using the fundamental theorem of calculus part 1. The first problem is problem number 12 on page 292. And this is the integral from 1 to 2 of 6x squared minus 3x. So 2 steps. The first step is to find an antiderivative. So let's do that. So term by term, I need to add 1 to the exponent and divide by that new exponent. So the antiderivative of the first term will be 6 over 3x cubed minus, for the second term, I add 1 to the exponent to get x squared, and I divide by the new exponent. So that's my antiderivative. Remember, it's not necessary to put the plus c. And then I take that from 1 to 2. Let me simplify just a little bit. That's the same as 2x cubed minus 3 halves x squared taken from 1 to 2. The second step is to plug in the endpoints and subtract. So first I plug in the 2. That gives me 2 times 8 minus 3 halves times 4 minus, and then I plug in the 1, which will be 2 times 1 minus 3 halves times 1. So when I plugged in the 2, 2 cubed was 8, and 2 squared was 4. When I plugged in the 1, 1 cubed is 1, and 1 squared is also 1. And then let's simplify. 8 times 2 is 16, minus 3 halves of 4 is 6, minus 2 minus 3 halves. 16 minus 6 is 10, and 2 minus 3 halves is 1 half, and 10 minus a half would be 20 minus 1 over 2, so 19 over 2. And this problem is actually a pretty good example of what happens in a typical fundamental theorem of calculus problem. The amount of calculus was kind of right up to here when we found the antiderivative. So this part was calculus, and this part is actually just arithmetic. So in a lot of problems, you end up spending most of your time just doing arithmetic. And if you're doing this on the calculator using your fraction function, then even that part isn't that difficult. Doing it by hand, the arithmetic can get kind of gross. Here's another example. This is problem number 20. The integral from 1 to 8 of the square root of 2 over x. So first of all, let's see if we can rewrite this to make it easier to find the antiderivative. First of all, I'm going to split the square root up as the square root of the numerator over the square root of the denominator. Since that square root of 2 is a constant, I can factor it in front of the integral. So I have the square root of 2 times the integral from 1 to 8 of 1 over the square root of x. And then I can use exponent rules to rewrite the 1 over square root of x as x to the negative 1/2 power. So these steps were mostly using algebra just to rewrite the problem so that I can apply the power rule. So I'm going to apply the power rule with n equal to negative 1/2. So I need to add 1 to the exponent, and negative 1/2 plus 1 is positive 1/2. And then I multiply by the reciprocal of the new exponent. And the reciprocal of 1/2 is 2. So just rewriting that a little bit, I have 2 square root of 2 x to the 1/2 taken from 1 to 8. So let's plug in the 2 endpoints and subtract. So first I have 2 square root of 2 times 8 to the 1/2 minus 2 square root of 2 times 1 to the 1/2. So that's 2 square root of 2 times the square root of 8 minus 2 square root of 2 square root of 1. The square root of 2 times the square root of 8 is the square root of 16, so twice the square root of 16 minus 2 square root of 2, the square root of 1 is 1. And then the square root of 16 is 4, and 4 times 2 is 8. So I get 8 minus 2 square root of 2. So I guess if we were to break this up into different parts, up to here is algebra. This step is calculus. And this part down here is algebra and arithmetic. So not a whole lot of calculus going on, except for finding the antiderivative. Now, in the future, we're going to see problems where finding the antiderivative is actually more work. And in fact, there's a big chunk of calculus 2, where we're going to learn how to take antiderivatives of lots and lots of different functions. In the next video, I'll give you a couple more examples from the book.